Hadoop exam learning resources. In this session we are going to cover the Apache Spark. So this is the new framework which is like after big data Hadoop development it came into the pictures. So we'll cover in this the introduction part, some features of this and the stacks, like what all components are part of the Apache Spark, and we will also see one of the very important point regarding the Apache Spark, that is RDDs, that surrounding RDDs of whole Apache framework works. Okay, then at last we will also see why what is good about the MapReduce and what is bad about the MapReduce, why Apache Spark, and at last why to use Apache Spark. So let me clean out the screen and let's go through this. Okay, so here I'll discuss regarding, first I'll say about the Hadoop, like exactly not too much detail I'll go into the Hadoop exactly, but basic things I have to cover here, like before moving into the Hadoop Spark. So what, whenever the Hadoop you think of, there are three things come in mind. That is, first thing is the file system, that is HDFS, correct. Second is the framework on which, like there are two framework on which Hadoop works, that is MR1 version 1 and second one is Yarn, that is recently not even recently is developed, but yeah, it came into the like since last 2-3 years. And the third part is a MapReduce itself. Okay, so one important point I want to tell you about this, Hadoop is in existence almost since more than 10 years. Okay, so it's no more new technology, exactly it has completed 10 years, so that's about, so it's quite mature technology now. Still the lot of development is going on. So why I'm showing here Hadoop is because Apache Spark exactly covers this area which is part of Hadoop framework. Other things would not change. So MapReduce, which is the programming framework or computation framework. Okay, so if I divide Hadoop in two parts, especially it is a storage engine, not storage engine as such, but yeah, you can keep lot huge volume of data. So this is exactly storage engine. So this covers under the HDFS. So this HDFS is the storage engine. The second part is MapReduce, that is called computational framework. So this is where actually your computation happens. So your programs move to the data where it is stored in the HDFS file system. So if you don't know the HDFS and Hadoop in detail, then go through the training of Hadoop professional training modules. So you will learn regarding this in detail. Okay, so nowhere is Hadoop going on because of Apache Spark. Apache Spark is leverage the Hadoop framework to process the data. Okay, so the main point here is the Apache Spark replaces this, not replaces exactly, because Spark itself uses MapReduce paradigm to process the data. Okay, but in their own what I say in engine, not on the Hadoop engine it would use it. Okay, so your data would be stored still in the HDFS, could be one of the part where the data is stored in the multiple machines, like exactly, so there are thousands of machines where your data is stored. So this is complete becomes your HDFS, correct. So above this Spark submit their MapReduce or whatever computation has to be done, like I would say task here. So that task in Apache Spark would submit. So this would make it. So why not to use MapReduce and go for the Apache Spark? What is the reason? What advantage it give? So very basic thing I want to say about this, Apache Spark is very fast compared to the MapReduce in the certain scenarios, not in all the scenarios, but yeah, most of the scenarios where the for which Hadoop is developed, the Spark is the faster one. So Spark runs on the Hadoop it could run with the Hadoop or it might not run with I mean, it depends like in what scenario you have. If you have already infrastructure developed in your organization for the Hadoop, then you can leverage this infrastructure to run the Apache Spark. Yeah. Okay, so you can use Apache Spark on the Hadoop framework. So the primary reason of using the Apache Spark is speed. It is fast. Like somebody claims it is 100 times faster than MapReduce. And so reason being, like some places definitely it is 100 times faster on some of the iterative algorithm. Like I will not go in detail about this algorithm right now, but yeah, this is where this is too much fast. Now in some places like it's 3 to 5 times faster. So this is like this depends on the like which scenario you are using the Apache Spark with compared to the Hadoop. So it's yeah definitely faster. So why it's fast? Okay, so let me just go back to the images we have taken. Okay, so which would help you to understand in detail. So I have to save the time. I have already taken the images. Okay, so now let's say you are processing your data in the Hadoop framework. Okay, so this is HDFS where your data is stored. So this is MapReduce one first phase, like you have chain of the two MapReduce to process your data. Correct. So this is splitting, mapping, shuffling, and reducing. So this is the first MapReduce where your data would be processed. So this data would be read here, split it, mapping is done, so mapper is executed and this data is stored into the disk over here. Then again this data would be read and goes to the reducing phase and write to the HDFS. Okay, so now this is again on the disk. Correct. Now again second MapReduce program start, it again reads from the this splitting mapping and again intermediate data stored into the disk. So this is again stored on the disk and then finally stored into the HDFS. So this way the every step whenever the data is like input output intensive job is there, then the in MapReduce framework the data is always written to the disk before putting into the next phase, whatever this is shuffling, sorting, or whatever. Nothing happens into the RAM in the memory. Okay, so everything first written to the disk and the data will again read from the disk. So you know like basic okay, let me tell you the difference here, why I'm telling you the disk and everything. So okay, let's finish this process first. Okay, so this is written to the HDFS and then read from here. Then whatever query you want to fire, you fire the query and read the results. So why I'm sure it's here focusing on the disk. Okay, so whenever you walk in the on any computer, you know like this is my disk, whatever is written. If I have to do some calculation or whatever, first it has to be read into the RAM. Okay, so disk to RAM, then you do the processing on the data. So and this is very like time consuming task compared to the like directly processing. If your data first needs to be bring up to the RAM, then process the data and again bring back to the disk. But what happens if you have the task which data is already reside in memory all the time before putting into the disk or anything, like after all the computation you want to do, then at last you put into the disk. Then what happens is like whatever data you process in the RAM would always be faster. So that is caching mechanism. You might have heard what cache is does. Cache is always keep your data in the RAM. Okay, so that is the advantage. So similarly in the big data world, even data is huge. Correct. A huge volume of data can be kept in the RAM. How? Because there are thousands of machines of cluster. So each machine has 4 GB RAM or 2 GB RAM. So they can store up to 2 GB or 4 GB data into the RAM itself. Before putting into the disk, this data would always be processed into the RAM. So that is the reason why the Spark is fast. Spark has options, like most of the time people will use this. That is the reason we'll use this, like to process your data directly in the memory rather than putting back into the disk and reading back into the disk. Here you can see in the MapReduce phase everything is written back to the disk and then read back to the in the uh, memory and then process, then this return to the disk instead of writing to the disk, directly putting data into the RAM whatever is available here, and then would be processed similarly like before putting. So it will save huge amount of time. So that is the reason for the sum of the time it is 100 times faster, because data is processed directly from the memory, from the RAM. Memory means RAM, random access memory. Okay, so data which is already, because computer always read the data from the RAM. So if your data is not available in the RAM, it will go to the disk and put into the RAM and then process the data. Data never directly processed on the disk. So this RAM is the magic point here with the Spark, which like bring the data or keep the data all the time in the memory until you are completed with the your finish your work. So that is the major or one of the biggest reason your Spark is faster compared to any other framework. So whatever, it's not about Spark. If any framework which is like directly work on the memory, then that would be definitely faster than reading from the disk. So like these are the previously in J2E and world or in any world you might have heard of the caching technology or data grid platform, JBoss data grid or anything you might have heard. So they keep the data in memory to process or to fetch the data. So whenever you want to fetch the user data, so user is already existing in the memory, then data would be given immediately to you. So that would be definitely going to 400 times faster. So that is the reason where the Sparks has magic to bring the faster. So speed comes from the fact that the execution can keep data in memory between the stages rather than persisting back to HDFS after map phase and reduce phase, where we have seen this. So it gives very well advantage for the iterative computations. Like iterative means like the things like on the data you process again, when a calculation applies, whatever result comes you again step puts on the one data comes in output, again process it. So this kind of iterative processing, so data all the time rather than putting into the disk, keep in memory and process it. So that is the reason where it would be become faster. So that for simple one pass, so this is iterative, that is good for simple ETL like work, where like what I would say specifically like cleaning of the data, you are just extracting and loading the data kind of phases where like RAM is not that much important. So where it is good you go for regular MapReduce, where there is no reason to use the memory for the processing the data. It's just extracting and loading ETL kind of work, single step work. So this is not iterative or interactive algorithms where you need really the memory to process, because you are not processing exactly, you are cleaning the data and just putting into the disk or something. So where this is regular MapReduce is good to have it rather than putting into this. So this is like batch oriented work we do, like regular basis you read the logs and put the data into the HDFS file system, little bit cleaning out like this data is not needed or this data is needed. This kind of filtering if you are doing that, MapReduce is good to use it. Another reason to use the Spark is it is not, it is very high, it provides the high level languages. Like as the best thing is like it is written in the Scala, which is like sorry, Scala is already like it is very good language when you are doing the parallel processing. So it is good on the threading and all these things like multi-threaded environment. So it is functional programming it uses. So the Scala framework is written in the Scala itself, and it provides the support for API to use written in Scala and can be used. Other than Scala, if you don't know Scala, then you can still use the Java on this with the Apache Spark. So it provides your Java support as well. So there are Python is also supported. So there are various version of the various languages are supported with this Spark framework. So that is the high level languages are available from, so where compared to MapReduce. So even MapReduce you can write in Java, any other languages, that is scripting languages. Sorry, but in Scala, if you write a code, you have to write very small amount of coding. Like whatever you do in the in the MapReduce, like huge code, you will write 100 lines of code. This kind of work you can do in Scala in 10 to 15 lines. So this kind of like, but you have extensive like very good amount of knowledge on Scala, that would be good thing. But I would suggest like we'll go through the Scala as well during this training session, so you will learn the Scala as well, so that would be good for you. So you learn a language as well as part of this training. It provides functional programming language, like we have already discussed. Like Scala itself provides this frame. Again, another framework like above this, I would like to discuss is. Okay, so let me go before this third diagram. Actually, before going this, so this is Apache Spark engine, which is written completely to process. So this is the engine, correct? Where this whole memory data process in the memory and everything. So this is above that there are various component are available. So a Spark SQL, so it has its own SQL as well as Hive interactive queries are supported with the Scala, with the Spark. So using, so we will not go in detail about each this topic, but I'll just tell you what is supported. So Spark SQL, so you can write the queries which are supported in Hive as well, so you can process it. Spark streaming, I'll let me go this what's streaming. Actually, I want to suggest, it's like whenever you see, if you have seen the like, sorry, uh, okay, so you might have seen the youtube.com, correct? So in YouTube, this is your video which is like Hadoop exam is describing something. So at the same time, whatever, these are the comment sections, correct? So whenever you are reading this watching this video, at the same time YouTube, like it's not exactly real time, but one of the examples, like somebody is uploading the another video related to the Hadoop, suppose, or recently uploaded. So based on the keyword you have provided on for your video, based on this, YouTube would suggest the which video you should watch. So some of the other videos, like this is good video by Hadoop exam. So similarly, if Hadoop exam is launched another videos, so these are also like this suggested, so these are recommended video, but that also supported at the real time. Suppose Hadoop exam recently uploaded one video and you just refresh this page, so the possible chance, like, there is a possibility, however that depends like how fast is this. I'm just giving an example, so that video can also come into the list. So this kind of listing could be possible. Or another good example is, suppose you are browsing the hadoopexam.com, okay, let's say, and you are trying to buy, whether you are in the situation like I would go for this training or should buy or not, correct? So in this game, like in the background, if this another scripting is running, batch is running on the data, because you're whatever you are browsing, like since 15 minutes you are browsing this data, go back to the server, and the server can real time process the your whatever actions happen. And based on this, like suppose the training price whatever is there, I'm just giving example, and you see the server see like this guys is 15 minutes and not in the situations to buy or something. So immediately like real time analytics can be done, and some like additional offer can be produced as a pop-up on the website itself, like you can get 10% discount if you buy just now this training within 10 to 15 minutes. So this time of this, I'm just giving, okay, Hadoop exam doesn't do this, okay, but yeah, I'm just giving the example, like this website, e-commerce website can do. If you are running browsing a product 2-3 times in a day and still not in the situation, like you are deciding whether I should buy it because it's costly or whatever reason it could be, so in the background you process your data or your log whatever is there, and based on that on the real time they can produce a pop-up and say like you can get the 10% discount if you buy immediately or whatever within 30 minutes. So this is your coupon code, something this kind of streaming, this can be done. So this kind of support is done, support is provided using the Spark streaming. Okay, that is one of the second component. Third is the machine learning library. So like that is what I would say, this is recommendation engine. So there are various algorithms and clustering, classification, part of regularizations, etc. So in the data science training we might discuss this. Okay, so this kind of things can be done with the map. So there's a pre-written algorithm are available, so you don't, if you don't have extensive programming knowledge, you can use this library. However, the programming knowledge is needed, but these are pre-built, so you can use this machine learning library. Similarly, GraphX is the another library like for the social networking, like LinkedIn, or like recently, okay, this is good example for us to advertise our new product. That is we have recently launched that is QuickTechie website. Okay, this quicktechie.com is a website for specifically for the uh, only for the .com. Okay, here just I'm writing. Okay, .com is only for the software professionals. So we are trying to collect all the like we have 11,000 subscriber at hadoopexam.com. So why not we create a network so everybody can use this network. So it is just in beta phase, we have just launched it. We have, so it give you the creating the good network kind of thing. So here what like GraphX library, so like LinkedIn you might have used similarly. So this one friend knows two other friends, so this kind of processing, like graph processing, like where network is important, like computer network itself comes into the picture itself. Okay, so this kind of processing can be done using the graph library. So where this whole what I would say, this is useful to use this graphics. So this is the component about the Apache Spark has. Okay, so these are the components. So okay, so crunch and cascading all. So this is, if you know this for the streaming, okay, there is a crunch and cascading kind of two framework were provided over the MapReduce for the streaming, correct? But still, like we have seen, like recently the Spark has performed better than crunch and cascading over the MapReduce because it still process the data in memory, and they use the I don't know what exactly in detail about this, but yeah, that these are still slower than Spark. So Spark wins over this. So mm. So Spark is a single project for machine learning, graphs, streaming, and SQL kind of thing. For the so so this is good framework. Okay, just a minute. One thing I wanted to go back is like regarding this topic. Yeah, second picture you can see. Okay, so like big data nowadays not only remained like batch processing like previously, whatever things happening, however many solutions have been developed over the Hadoop to provide the real time, near real time solutions. But like exactly like Spark wins over the many things. So like if you really go for the big data solutions, so like recently we have, I read somewhere, so these three things has to be suffice, like batch processing should be there, streaming should be there, and interactive. What interactive means, like uh, interactive means like what I would say, huge like database you have, like HDFS or something, in HBase or something, and you should be able to fire ad hoc query, like in the Hive, you know, the in Hadoop you can fire the ad hoc query and get the data, or data scientists can fire the ad hoc query and fetch the data. But these are still slower because they underline use the MapReduce. So this interactive query needed the faster response, so Apache Spark also supports it. So combination of all these three things, if one product provides, then that is called the real big data solutions in nowadays. So that like the requirements keep coming for the new things, like everything is being advanced, and the requirement comes, like previously we never heard this kind of things, but nowadays like technology is improving, requirement is coming, people are learning more and more on this, and young scientists and data scientists are keep coming with their new ideas. So this, so definition also keep changing regarding big data. Before that we would have different little bit different definition of the big data, but nowadays like people expect under the big data it should support this all machine learning, batch processing, streaming, interactive, iterative algorithm, everything, and the library should be available. So this comes here. Okay, so MapReduce was batch oriented, correct? Here, like in the nature. So any framework on top of the MapReduce would also be batch oriented, like Hive, Pig, and etc. For iterative processing, as in case of machine learning, we see like interactive analysis, Hadoop, R, etc. So these are the requirement is done through this different technology, but like Spark provide this also. However, there's no worry about like people who are working on the Hadoop because of Spark. Hadoop is not going anywhere. Okay, because Spark is another framework which leverage the Hadoop framework. Like which organization already have big infrastructure of Hadoop have already been created. So like so somewhere MapReduce is still good. Actually, you don't have to write them Spark for them, but wherever it's possible, you will obviously use the better things, which is give you the faster results. But Hadoop is nowhere going. Yeah, it means you are not losing your learning whatever you have learned with the Hadoop. Okay, so it will definitely help you because the Spark also has the concept of MapReduce and a kind of algorithm, but they have been written in their own language like Scala or Java kind of thing. So, Spark is designed to perform both batch processing similar to MapReduce and new workload like streaming, interactive queries, machine learning, etc. So that is good to use for Apache Spark. Spark has been used like one of the example like benchmarking. If you remember, I don't know you have visited or various sites. Like every tool has been benchmarked against one of the sorting algorithm on the 100 terabytes of data. So which framework whoever like process the faster would win this race. So previously Hadoop was the winner, but nowadays Spark is winner, like which has like 100 terabyte of data has been sorted 8 times faster with the only one third machines of the like Hadoop uses. Suppose Hadoop uses 1000 machines to process the 100 terabyte of sorting. I'm just giving an example. So using the Apache Spark, it has been proved it is 8 times faster on the only they have used 334 machines. If we sorry 1/10 of the machine, so like only 100 machines, sorry. So whatever is done on the 1000 machine can be done using the 100 machine and 8 times faster. So you can see like how fast it is. But sorting is an iterative algorithm, so where you can really, because you sort the data in the first step, then you again sort it, then you again sort it. It depends what kind of algorithm you have used, but again, so like this is iterative algorithm. You keep doing the sorting, the similar step keep applying on the data set. So this really it gives you the faster. So this is 8 times faster. So then the largest cluster which has been created up to with the Spark is 8000 nodes. Okay, so that is very good clustering size. Okay, here even Hadoop support, like with the yarn, like 10,000 more than 10,000 node cluster has been supported. So it's like Hadoop again infrastructure wise win, but 8000 size of cluster is also very big cluster. So it's nowhere we can say small cluster. So this is one of the like I'm giving just example. uh, okay, so now let's move to the little bit more on this Apache Spark in little bit more on the what I would say concept and component, small component which are being used like RDDs and all that thing. So uh, let me start with here with the RDDs. Okay, what is RDDs? Like that is very important concept you have to learn. It's like no avoidance for this RDD. To learn the sorry Apache Spark. What is the full form is resilient distributed data set. Distributed data set. Everything is distributed in the Hadoop world, Spark world, or because now commodities, machines, and everything. Okay, so what exactly that every term means here? It's like I would divide this in three step. Resilient. Okay, resilient if data is in memory is lost. As we know, like everything Spark process isn't remain in the memory. It's not necessarily in memory. You can configure in the disk as well, but as you configure on the disk, then it would be performing slower. So let's assume we are considering everything is in memory. Okay, so if your data which you are processing, which is somehow the data is lost, in the memory, and this data is no more available. So what exactly Spark can do? It can recreate. So suppose let me give you an example how it can recreate. Okay, so suppose this is your data set, first data set. Okay, this is first data set. You have processed some data, some calculation you have done here, I would say C1. You have again processed this data, some calculation C2 you have done, another processing you have done, and C3 calculation you have done. So now Apache Spark knows what phases this data set has done. Three phases. Now after this new data set has been created X, now suddenly machine crashes or something happen, node crashes, this data has gone, this X is lost, nowhere this data is available. What Apache Spark knows, like whatever data calculated on available on this machine has been lost and nowhere it is stored. Okay, because no disk is available. What it does, it says I have done three calculation on these three data points. Sorry, on this data point, this three calculations are done, and I come to this value X. So what exactly it does is like again recalculate the value based on this three calculation and create the X value on the another node. So this way, if any data is lost from the memory, can be recreated. So that's why this RD this data set is called resilient, distributed. Obviously you know this data is distributed among the multiple machines on the cluster. So you have thousands of machines on the cluster, so data is distributed across the cluster, and data set is a data set. Okay, so this is data set. Initial data can come from a file or created programmatically. So you can just imagine. Okay, just I will give you the pictorial diagram. So you just imagine RDD is look like this kind of thing, and every line has a one, like I would say not exactly, but yeah, I would suggest you pictorially pictorially you can remember this thing. Like this is my RDDs which has four lines right now, and four exactly what I would say, not line. Okay, let's consider as a line right now. Okay, we'll come to the term again. uh, so this is how your RDD look like. So RDDs are the fundamental unit of data in Spark. So whatever operation like C1 calculation is done on the R1. If C2 is done, so new RDD is created out of the C1 calculation. New RDD would be created. I would say new RDD. So C2 would be executed on this. Out of C2 calculation, new RDD would be created, and then is called C3 and C4. Kind of this to X is again new RDDs. So whatever you operation you don't do in Spark is mostly done on the what I would say RDD. Most of the Spark programming is performing operation on RDDs. Okay, which we have already discussed. Okay, so RDDs are fault tolerant, read only collection of elements that can be operated in parallel. Okay, so these are read only. Nobody can manipulate this data once it is created. You can just perform calculation on this and create another RDD, but this RDD won't be altered or cannot be modified once this is generated. Okay, so this is fault tolerant and immutable. I would say if you are Java guy, you can understand in more detail. So like immutable, it cannot be altered. So RDD is cached in memory or on the disk. If this RDD can be cached so in memory, so it is better if you put in memory to faster processing, or it can be stored in the disk as well. Okay, so let me give you an example how RDDs and all this thing, which I have already created this example for you to give you the faster understanding. So suppose I have this is file. This is my file content. This file name is Hadoop exam.txt. Hadoop exam.txt is a file name. This file contains three lines. Okay, and I would say this is SC means Spark context. I would not go in programming right now. Okay, so sc.text file, I would say this is a text file. Okay, and I provide that this Hadoop exam.txt as the input, and it will create a new RDD that is called my data. So out of this new RDD would be created, and you can see here three separate line would be created. So this is divided each row on per each as per each line out as an output of RDD if you read it, and you can work separately on each row or whatever way you want to do it. Okay, so it depends on your requirement, correct? So now let's move further. So this is my RDD has been created, and I will just on my RDD I will fire a function. So this is my data dot count. Let me give me the count. So it will give you output as a 3 because this there are 3 lines. My data dot first, what it will take out the first line and print the here. So this is another RDD will be created out of this, and this is called, this is the contains the first line of your text. Okay, so this way this RDD works. Actually I will not go in too much regarding RDD programming right now, but I will give you the this just to understand starting point of the our whole training. So now this RDD has two type of operations. Specifically, first is called actions. By name you can understand. Second is a transformation. So I would go first transformations. However, transformation means while doing the operation you can transform to the another RDD. So let's give you the example. This is one of the RDD. This contain www.hadoopexam.com. Okay, after transformation, so what kind of transformation you are doing? I'll just doing like line dot to uppercase. Okay, so I'm just saying like as a programming technique, I just change this line to the uppercase. Whatever is in the RDD change into the uppercase. So new RDD is created by the during the transfer. However, this RDD won't be altered. This is immutable. This would remain as it is. Okay, so now this RDD would be created as an output. That is the completely uh, uppercase data, correct? So this way this you can do the transformation. So that is one of the example of doing the transformation. So what are the example of the transformations are filter, union, mapping, group by, reduce function, etc. are the transformation functions are available in the to work on the RDDs. Another one is action which returns the values from the RDD. So like in our example, so this is my data dot count. What exactly is this? This is an action which we have done. Like give me the count. There is no transformation as such, correct? It just give, it has part one functions to get the data. So count, take, first, collect, forge, etc. Is these are the actions which produce an output, and then it could be like any value which you needed. So this is way these are the two important things over the RDDs you can do it, actions and transformations. Okay, so now let's move to the next is types of data in the RDDs. So RDDs can hold any type of element like primitive data types. If you are, I don't know you understand primitive or not, but it's if Java guys or something, so you can understand there are two type of data, primitive and object type of data. So int is like one of the primitive example, and integer is an object. Correct, object remains in the heap memory area and this remain in the stack area kind of thing in the Java, if you understand. So this primitive elements can be supported by the RDTs, characters, boolean, strings, sequence types like list, arrays, tuples, dictionary, etc. We'll go in detail about this in the further modules of training. Scala and Java serialized object, mixed type of this, all you can store this. There are some advanced type of RDTs which we will not discuss right now. So that's the all about RDTs in this part. So let me move back to this blank screen. Okay, okay, so use with MapReduce algorithm, you can use Spark with the MapReduce algorithm, correct? I'm just summarizing here, like you can use into the MapReduce, not summarizing this tutorial, this training, but just concept. Many additional functions are available, common data processing like sorting, joining. So like by writing lesser amount of code, sorting, joining, group by union, etc. You can do it. Spark implements MapReduce with much greater flexibility. Map and reduce functions can be interpreted results stored in memory, and operation can be changed easily in the Spark. Okay, so that's reason. Okay, so now this is regarding Apache Spark, but let me go back to the MapReduce. What we have done, like it's MapReduce not at all bad. Okay, so I would say, so don't worry, whatever you have learned from the regarding Hadoop, you will know where it going to go. So it's a good thing about it's fault tolerant. Obviously, that is the main purpose of the Hadoop, fault tolerant. Correct. Now second is optimized for input output path. It's very optimized if you're writing and reading from the disk, okay, not from memory. So these are very optimized, very their own serialization mechanism. They have written scalable. You can runtime, you can add the node and etc, and you can scalable running job can be executed on the new nodes kind of thing. Developer features focuses on MapReduce, not on like infrastructure. You have to just write MapReduce code and not on the map, because infrastructure is some other person's responsibility, not developer responsibility. And next is a simple API. I would say obviously it's not that complicated. It's a simple API. Now in case of Spark, you have to learn Scala. That is new things come. If you are Java guy, then MapReduce would be like good for you. But like learning Scala is also good because it's very fast and multi-threaded, and regular life also it's make easy for the especially parallel programming. So where the MapReduce is bad is it's optimized for IO, but for the disk IO does not leverage the memory at all. MapReduce doesn't use RAM at all to process the data, correct? It won't store in the memory, and iterative algorithm go through the disk input output path again and again. It's even optimized, but yeah, it has to go again, storing into the disk and getting back to the disk. So this is the problem. And a key in key out, their own data types they have supported, like you have to use their own data type. Even basic types of join require extensive code. Yes, obviously lot of code to be written to process the data using. Spark is 2 to 5 times faster on the many of the 2 to 5 times lesser code you have to write in case of Spark. So that is the where MapReduce a little bit uh, behind compared to Spark. Access your Spark access your existing Hadoop data. Obviously, let me clean out again. In case of Spark, sorry, in case of Spark, it can use your existing data, so you don't have to like store again. Obviously, for storing the data, you have to have used the Hadoop framework, because there's no other infrastructure to support this volume of data to be stored. So your Hadoop is nowhere going again. Okay, yarn based deployment, it provides like new framework like yarn, which is MapReduce 2. Again, it's a 3-4 year old framework. Mesos based deployment, there is another framework to clustering. For the clustering, Mesos based deployment, deploy on existing Hadoop clusters. You can deploy it. RDTs track the lineage implementation information that can be used to efficiently recompute the lost data, which lost data can be recomputed, which we have already discussed, like how it can do it. Variety of storage level, like yeah, sorry. So this is the important point here. Like we had keep saying like the Spark is memory, store data in memory, but yes, Spark also support data store data in the disk as well. So this both are supported. You have to configure. Now sometimes your data is huge which cannot possible to store completely in the data, then you have to use the disk. There is no options, correct? So like you have 4 GB RAM, but your data calculated which is 6 or 7 GB data, then you have to keep some data into the disk and some data into the memory, so which accordingly you can get the benefit of the regarding the what I would say. mm, yes, Spark. So that is all about the Spark introduction part exactly. So we'll go in further modules regarding the in-depth training of the Apache Spark, and we'll do some hands-on session as well if possible. So that's what. Let me give you some new product we have launched, like regarding like not exactly training or module. So this is quicktechie.com. So quicktechie.com, where we are creating, like, this is still in beta stage, where we're trying to connect all our learners on the single platform, and if anybody else want to join it, so you can create your own articles here. You can like join the groups actually, which is like, however, this is not too much flexible right now. We have some controlled environment on this, but yeah, some sample profiles have been created over here, so you can see like how it works kind of thing. So you can learn here. Sorry, sorry so it's, yeah, this is like little bit slower right now, I don't know, but yeah. So these are the profiles you can create it. Like, let me give you one of the examples so you can check what exactly this contains. It seems to be little slower. Yeah, it's coming up actually. So my net could be slower or something else, or website could be slower, it depends. Again, so you can search your profile kind of thing. You can create connections like in LinkedIn and something you have seen previously. So I go to this profile. This has better informations, like you, it's like you can your profile user, sorry, your name coming here, your according to image you can select as per your technology choice. Right now, this is your profile title. You, this is current employer, previous employers, like kind of on LinkedIn you might have used. So like about me, it has more detail about you, your blog details, your certification, your patent, your projects detail. You can add it. We are still in the fine grading this thing. So these are the articles you can post here. These are the connections you can have, who has viewed your profile kind of thing. And these are the groups where this we are creating. So our group would be not publicly like created. This would be created by admin itself. So this is controlled, like not like spamming, or we are allowing here. Like it's good for you if you join it, because we can be connected, and using the single search we can, like, in our admin can contact and give you the better like in case of job offer or whatever, it can be directly contacted to you. So this is one of, and our obviously fast famous is hadoopexam.com. We are keeping trying to improving. If there is any problem, we are keep adding the new product, so you can visit over here. So this is hadoopexam.com. This is like whatever here you can see, like we have keep adding the products. And so I would suggest you keep visiting this website, because we are keep adding in big data, cloud domain, and data analytics, and many other training we are keep adding. So thanks for listening, and I hope you liked it.